Hey everyone, welcome to this review note. In this video clip, we're going to be looking at storage on a Linux system. We're going to be doing logical volume management. We're not going to worry about physical partitions in this particular case. As you can see, I've already got my Linux machine booted up. I'm logged in, so we can get started. Now, just so you know, in order to save a little bit of time, one of the things that I've done is created the 3 disks and added those onto the VM. They've been scanned in, so they're now visible to the Linux system. Just did that with a reboot. Now, in order to get started, first the command that I want to look at is how do we see what actual disks there are that are attached to the system. There's a number of different ways to do that, but one of the easiest ways to do it is with a command which is fdisk. Fdisk has been around for a long time, same as the name of the command that Microsoft was using with the DOS systems originally. And what we want to do is simply list the different devices that we have. You should be kind of getting used to now that the L option or any kind of a command that starts with L is going to have something to do with listing. So what I'm going to do is sudo, considering that I'm logged in with my non-root account, although I do have sudo capability, fdisk-l for list, and that's basically all I have to do. It's going to prompt me for my password, and we'll be able to see with the output all of the different devices that we know about. Now you recall that as far as the disks are concerned, with SCSI disks, we have /dev/sd and then some sort of a letter that indicates the disk, and if there's a partition on it, it'll be a number after. So for example, if we had partition 1 on the first disk, which would be labeled A, that would be SDA1. Now in our case, we are not going to put partitions on the disks that we're going to use for logical volume management. We're just going to consume the entire disk. And you can see the last 3 items on my output here. There's a /dev/sdb, a /dev/sdc, and a /dev/sdd. Each one of those is a 10 gigabyte disk that's attached to my VM. And I haven't done anything else with those disks yet. Now with logical volume management, remember that we have 3 different types of objects. First, we have physical volumes, or PVs. We take physical disks or partitions if we need to, and turn those into PVs or physical volumes so they can be managed by the logical volume management software. Second thing we have is volume groups. They basically aggregate a number of physical volumes into a volume group, which can be logically divided up. The third item is the logical volume. That's what we actually get to access. So a logical volume will consume either part or all of a volume group in order to present that storage out for us as users. So let's start off with physical volumes. 3 things that we have to remember is those 3 groups of characters, PV, VG, and LV. All of our commands are going to be related to those. So if I want to know all the commands that are related to physical volumes, I can do PV and then tab, and I'll get a list of all of those. So I've got, for example, PV change, PV check, PV create, move, remove, resize, that type of a thing. So we've got a lot of different commands here, but the ones we normally use are create in this case, and we also use PVS, which basically displays kind of the status of physical volumes. So I'm going to do PVS first, and I'm going to have to sudo this, again, because I'm not logged on as the root. And we can see that right now we have 1 physical volume. That's /dev/sda2. We want to create physical volumes out of SDB, SDC, and SDD, those 3 disks that we added in. So as you can probably guess, out of all the PV commands, PV create is going to allow us to create that volume. So I'm going to do sudo and then PV create /dev/sdb, and it tells us that we have a physical volume that is created successfully. And to do the same thing with SDC and SDD, so I'll just up arrow, get rid of the B and put a C in. I can do an up arrow, get rid of the C and put a D in, and I now have my physical volumes. If we want to go back and now look at the status of all of our physical volumes, I'll just go back to that PVS command, and now we see the additional volumes that we have. So SDC, SDD, we can see that they are all 10 gigabytes in size. We can see that they're all 10 gigabytes free. So basically what that's telling us is that we have not consumed or used these physical volumes for anything yet. So that's first step, fairly easy, fairly straightforward. The second thing we want to do is create a logical or a volume group from these physical volumes. So how do we do that? Volume groups, VG. So if I do VG, tab, and we'll see that we've got a number of different things that are related, commands that are related to volume groups. With others, we have VG check, we have VG create. The type of a thing, we can merge volume groups if we want to, we can split them if we need to, but in our case, what we're going to be doing basically is creating. I'm going to go back here and I'm going to sudo once again, and then on the end I'm going to do VGS to see what the state is. And we can see that we have a single volume group called CentOS. That's the one that gets created when the virtual machine is created. Assuming, of course, that we use the default partitioning or storage configuration. Our job now is to create the volume group out of those 3 physical volumes. So I'm going to do sudo, I'm going to do VG create. So that is the command. I need to specify the name of the volume group. So this is going to be, in my case, I'm just going to use VG1. And then I have to specify which physical volumes I'm going to include, and I just put those out in a list. So I'm going to do /dev/sdb space /dev/sdc space /dev/sdd. So all of those physical volumes, I don't have to do them all right now if I don't want to. I can do a lot more than that, but if it comes down to the point that we need to add extra volumes in, all we do is say VG extend, specify the volume group, and then whatever physical volumes we want to add in, and it's pretty much that easy. So I'll hit enter here. We can see that the volume group was successfully created. If I go back and do VGS at this point in time, I can see I've got my new volume group called VG1. One of the things that I can also do, I'm going to sudo and I'll do VG display, and I'll do that on volume group 1, VG1. And I can get some information from here that's kind of interesting. So for example, you can see how many physical volumes are included at this point in time. We can see that it is a version 2 logical volume manager. We cannot at this point in time see what physical volumes are included, but that's okay. If we want to look at physical volumes now, I'm going to go back and I'm going to do a sudo and a pvs physical volume status. And the reason that I do that is notice now that SDB, SDC, and SDD have a volume group associated with them so that we can see it's volume group 1 that's associated. So we got 2 items done now. We've got our physical volumes created. We got our volume group, which is now consuming those physical volumes. The last thing that we have to do is actually set up our logical volumes. So what I'm going to do, again, LV, right? So if I do LV and then tab, we can see commands that are associated with logical volumes. And a lot of them are the same as what we saw before. There's LV create, there's LV display, LV extend, LVS. If we want to look at the state, we can do resizes, we can do renames, we can remove them, all kinds of things that we can do. Main things that we typically do with logical volumes: create, remove, extend. Those are the primary actions that we take. Now I'm going to do an LVS. Let's go back and sudo this so that we can look at the status of logical volumes, and we can see that right now we have 2. One is called root, the other one is called swap. Root actually is the logical volume that gets mounted up to the file system root. Swap is the swap volume that is used for swapping, since in the Unix systems we do not use page files, we actually use partitions on the disks if we need to page in and out. Now in our case, what we want to do is create a logical volume, and that logical volume is going to be created consuming part of our volume group. So our command is going to be lv create. So I'm going to sudo and then lv create. Now I have to specify the size. I'm going to specify an absolute size rather than relative. So I'm going to do -L. I'm going to make it 5 gigabytes, so 5G. I have to give it a name, -n, and we'll call this lvol1. And then I have to specify which volume group I'm going to consume, so that'll be VG1. And that's basically all I need to do. I'll hit enter, and my logical volume group is created. I'm going to make a second one. I'm going to make it 2 gigabytes instead. So I'll do sudo lv create. I'll make this one again capital L, 2G, name lvol2, and then we'll consume VG1. I'll go ahead and enter that, so I've got my 2 logical volumes created now. If I go back and do LVS once again, we can see that we have our new logical volumes created. So we see lvol1, lvol2, which is consuming volume group 1, and the size, 5 gig and 2 gig. If I go back and now look at VGS, volume group status, I can see that volume group 1 now has not only the 3 physical volumes, but we can see it has the 2 logical volumes assigned to that, and we can also see what the sizes are from that. So far so good. Now the logical volumes basically act like partitions on our normal systems. So what we're going to have to do is create a file system. The way we do that is with the mkfs, or the make file system command. So I'm going to say sudo. Well, before I do that, let me back up for a second. One of the things that ends up happening when we create logical volumes is we actually get devices, if you wish, or file system objects that are going to be in the dev directory. So if I do a listing of /dev, one of the things that we're going to see in here is our volume group. So over near the bottom on the right hand side there, you see VG1, which is the volume group. And if I display the content of that, or a listing of that, then we can see inside of that lvol1 and lvol2. So essentially what we need to do when we're dealing with logical volumes is we do the pass /dev / the volume group name, so in our case VG1, and then / and the actual logical volume itself, so lvol1 and lvol2. All right, now we bring that up because we need to create a file system. So we do mkfs, have to sudo that of course, mkfs, and then we can specify the type of file system. So we're going to use the newer file system that we see in the Red Hat 7 version, which is going to be XFS. So I say -T for type, and then XFS is going to be the type of file system. And then I have to specify the path to where that volume is that I'm going to set up. So this will be /dev /vg1 /lvol1. And as soon as I have that in, I just say enter. And it's that quick. The file system is now created. So that's kind of like doing a format in the Windows world. I'll do the same thing for lvol2. So I'll just up arrow and then change the 1 to a 2 on the end. I'll hit enter. And now I've got the file systems created on those 2 logical volumes. So basically now they're formatted, if you want to call it that. And the only other thing we have to do is actually mount them so that we can access them. Now again, this is something a bit different than what you've seen in the Windows world before. With Windows, when you format something, typically it says, hey, do you want to assign a drive letter to it? And we say yes. And then what happens is, in the process of assigning that drive letter, the volume actually gets mounted so that we can access it. Since we don't have drive letters, that's a bit different here, but that's okay. we use the mount command for that. So a few different things with mount. If you simply specify the mount command and nothing else, it's going to tell us what file systems are currently mounted. So if I say sudo and then just hit mount and nothing else, then we can see there's quite a bit of output here with respect to what file systems are mounted. Most of this probably doesn't really matter for us a whole lot, but the one thing we can see if you were to hunt down through here is you would be able to find the file system root, and you can also find the boot directory that's mounted. And in fact, that is second or third line up from the bottom. You can see that /dev/sda1, and that is mounted to /boot. So that's basically where the kernel lives when the OS loads up. Now what we can do is we can manually mount, which is not persistent, it will not survive a reboot, or we can persistently mount, which means that we will be able to survive a reboot. So I'll show you first how you go about mounting manually, and then what we'll do is we'll make it persistent. Now when you mount, there's no drive letter in Linux, so we have to have some sort of a directory to mount to. And what I'm going to do is create two directories in the file system root. I'm going to call it lvol1 data and lvol2 data. So I'm just going to say sudo make directory / lvol1 data and a second one lvol2 data, and go. If I do a long listing now of my file system root, we can see partway down there, about halfway down, is lvol1 data and lvol2 data. Right now, if I was to create any file system objects inside those directories, they would be on the partition that is mounted to the file system root, but that's not what I want. I want this to go up to these other volumes. So we have to mount those. So what I'm going to do is I'm going to say sudo and then mount. We have to specify the file system type, so I'm going to do -t, and if you remember, we created an XFS file system, so this is going to be the same, the XFS. And then after that, what I will do is say, what device do I want to mount? So I'll do /dev /vg1 /lvol1. So if you remember, that's the device that we made the file system on. That's the device we're going to mount. And then we specify the directory to which we're going to mount the device. So /lvol1 data, which is the directory that we created for that. I'll hit enter, and basically that's all I need to do. If I do a listing of /lvol1 data, we can basically see there's nothing there because we haven't created anything yet, and that's absolutely fine, but it works. We can get into that. Now, as I said a minute ago, mounting that file system is not persistent. If I was to reboot the system right now, that would not be mounted when the system came back up. And you might want to do that sometimes, but more often than not, when we create these volumes, we want them to be mounted when the system boots. And the way that we do that is by modifying the file that contains all the information about the volumes that needed to be mounted. So the first thing I'm going to do is unmount what I already have. And the reason I'm going to do that is I'm going to change the config file and then test it. We always want to test before we do a reboot, because if we mess up the config file that talks about how we're going to actually mount our volumes, when it boots up, if those volumes cannot be mounted, the system is going to hang on the boot and we're going to have to go and fix that. So we'd rather not have to deal with that. So unmounting something is very simple. I'm going to sudo, and then you do umount, not unmount, but umount, and then the directory that's mounted. So this is going to be /lvol1 data, and I'll hit enter, and that's now unmounted. Now the file that we have to change is called fstab or fstab, and that's located in etc. If we take a look at that file, I'm just going to say /etc/fstab, and I'll hit enter, and we can see that there are a couple of items in here that are going to mount. The very top one that says /dev/mapper /CentOS root space and then /. So that's a logical volume that is going to be mounted to /, which is the file system root. And then we see after that XFS. So what that's telling us is that we are actually going to, every time the system boots up, this is the logical volume that we are going to mount to the file system root. Okay. Underneath that, we can see something that says UUID, and then a fairly long number after that, and /boot. The recommended practice these days is to use the UUID instead of a path. And the reason that we would do that is if somebody managed to get their hands on our system and substitute a different volume, we could end up mounting something we don't really know what that is. It's very easy for somebody to stuff something else into a path. On the other hand, it's very difficult for them to spoof the UUID, or it's much more difficult, we'll put it that way. So we recommend using the UUIDs. I'm not going to do that this time around because I want this to be a little bit clearer on what we're doing. So I'm going to queue out of that. Now, one of the things that we always want to do is make a backup of a config file before we do anything with it. So I'm going to say sudo copy cp /etc/fstab, and then that's going to be the source, and I'm going to copy that to etc/fstab .old. And then I'm going to edit the fstab file with a text editor. So I'm going to say sudo vi /etc/fstab. Man, I need to type. There we go, we're in. So I'm going to add a couple lines on the bottom of this. So I'm just going to arrow down. I'll go to the end of the line, and I'll insert, come to right past the end of the line and hit enter. So the first thing I need to do is specify the path to what I'm going to mount. So I'm going to say /dev /vg1 /lvol1. I have to specify the directory to which that's going to mount. So I'll tab over and say /lvol1 data. Tab over here, this is going to be XFS. The format is not super important as long as you have some white space, but it's always nice to make sure that everything lines up. Makes it a lot easier to read the file. Defaults, I can specify things like, is it going to be read-write, read-only, what's going to be the UID that's going to own the volume, that kind of a thing. I'm just going to use defaults here. And then also, we can specify when the file system check takes place during the boot cycle and how often. I'm just going to put this as 1 which means that this is not going to be critical for file system check, nor does it have to be mounted before the boot starts. So I'll keep that, and I'll do the same thing with lvol2. So /dev /vg1 /lvol2. This is going to mount to /lvol2 data, and the file system is going to be XFS, defaults, oops, and then 1 and 1. So that's it. I've got my two lines, and I've typoed something. Let me go back and fix that. There we go. I've got my two lines in there. I'm going to mount lvol1 and lvol2 to lvol1 data, lvol2 data, XFS file system. So this is basically what will happen is when the system boots up, the mount command, or the mount is going to be used as this file gets read, and we'll mount every single one of the volumes in here. So I'm going to mount file system root. We're going to mount /boot. We're going to mount the swap file, which I didn't really talk about. That's the third one down. And then our two volumes, which are lvol1 and lvol2. When I'm happy that this is set up right, I'll just escape :WQ for writing quit. So my file is now saved. Now here's the trick. I want to make sure this is going to work. I don't want to reboot the system sometime, maybe months down the road, and all of a sudden it hangs on the boot because I messed up the fstab file. Really, really easy way to do that. So when I do the mount command, I can specify -A. What -A is going to do is say, I want you to read the fstab file. I want you to process everything in the fstab file. If something's already been processed, it's not going to redo it. So we know that, for example, the file system root is mounted on /. It's not going to unmount or anything like that. But the two new lines that I put in have not been mounted yet. So it's going to actually execute those. And if there's an error when it executes them, that gives me the opportunity right now to fix that problem before it's sometime down the line and nobody knows what's going on anymore. So I'll just say enter. That comes back with absolutely no output, which means it was successful. And if I now just issue the mount command, and if we look down at the very bottom, the last two lines, you can see /dev/mapper/vg1-lvol1. Now, why is it not exactly what I did with dev, vg1, and lvol1? Because those are symbolic links that point to different file system objects, so it basically uses the actual value rather than the symlink. It tells us what partitions are mounted on, it tells us their XFS, they are read-write, and then several other attributes as well that I'm not going to worry about right now. And that's basically it. So now, again, I can go off and start storing data in lvol1 and lvol2, or sorry, lvol1 data and lvol2 data under the file system root, and I'm good to go. So although there's a lot more to storage management in Linux, that's basically all we are going to be covering. Hopefully this has been helpful for you. That's a wrap on the video, and we'll see you next time.